Good morning or good afternoon, depending on which class you are looking at this. This assignment, which is called Counting Trees or Counting Techniques, gives you a way to figure out how many possible choices you would have in any one situation. Some of you guys have hopefully seen this before or understood it because you've heard of this. This is a typical choices question. So when we were playing Yahtzee, you guys were rolling a die. And each time you did that, you had the choices of 1, 2, 3, 4, 5, or 6. So what is the probability then of rolling a Yahtzee? So when you're talking about that, you have a 1 in 6 chance of rolling any number, 1, 2, 3, 4, 5, or 6. Sorry, my pen's not cooperating here with what I want to write. I don't know why. There we go, 1 in 6 chance. And let's say that you roll or choose to roll a 5 because you got a 5 and a 5. So there's the first dice. There's a 1 in 6 chance. There's a 1 in 6 chance then that the next one is a 5. There's a 1 in 6 chance that the next one is a 5. And then let's say that, so I've got 3 5s right now. I'm going to get a 4 here and a 3 here, or something else random. So to get any other random number, there is a 5 of 6 chance to get that one. And then there's a 4 in 6 chance of getting that last one, assuming they're all different. And what I'm going to do is multiply all these together to understand the probability of rolling that particular outcome. So if I wanted Yahtzee, I'm going to change these to a 1 and this to a 1, and I have 1 over 6 to the 5th power. And 6 to the 5th power is a pretty big number. It means 6 times 6 times 6 times 6 times 6. And that 6 to the 5th power is 7,776. So right now I have a 1 in 7,776 chance of getting Yahtzee. So those of us who played the last couple days and did not get Yahtzee, that's why. So now let's look at some of these other possibilities, or what do you do with this? Usually when you're dealing with counting trees, you are going to draw this, which eventually becomes tedious, but I'm going to use this example here and kind of explain the picture that's not showing up on here. So the picture is called a counting tree or a tree diagram. And this tree diagram then helps to explain or label, is what you'd normally do, all of the possible outcomes. In this case, we're talking about burgers, drinks, and desserts. So up here it talks about the kind of different burgers. So I'm just going to choose the single. So assume this first line down here stands for the single burger. So I want a single burger with milk and then a cookie. So that's this path right here. I could have a single burger with a soda and then a cookie. And it goes this way here, cookie. I could have a single burger with a juice and then a cookie. And there's those 3 paths. So by the time I list all of these possibilities out, single burger with cheese and milk and a cookie, single burger, cheese, soda, cookie, and then change the desserts to ice cream, if I end up counting all of these knots at the end, that tells me how many paths I get. But there's got to be an easier way to do that because nobody wants to draw this out. It gets pretty tedious. Some of us aren't very good at drawing these beautiful straight lines. I really wish I was teaching this to you because you would see I'm terrible at this. But it talks about that there are 24 different paths. How do you get that? Well, here's the burger choices, and I have 4. Here's the drink choices, and we had 3, soda, milk, and juice. And then I have desserts, and I had 2 choices for that. So if I multiply these together, 4 times 3 is 12, times 2, there's my 24. Now, I like to call these seat problems because notice I just drew kind of like a place, a seat, to put these items. So as you go through this investigation, you're going to look for ways to write out those seat problems. As you go through this investigation, look for each activity. It's going to ask you to write out, it's going to ask you to draw out, and it's going to ask you to do those calculations. There are different activities where I have given you the seats, and you're going to do this on your own and think about what is happening here. When you get to the combinations, they become a little bit more difficult. And when I'm talking about words are like, ha ha, that's not really a word. DCK is a word. I know it doesn't make anything, but that's what it's asking you to think about. What I will do later today is post some helpful hints and some answers to this, but I do want to see your thinking and your work. And please let me know what help you need.